Good morning, everyone. Welcome back to our sessions on classification algorithms. So, I'm extremely sorry for the inconvenience that was caused yesterday. But anyhow, let us resume where we have stopped in the previous session. So, as part of this playlist, we are concentrating on classification algorithms that are part of supervised learning, right? So, we understood naive Bayes algorithm, then we also implemented naive Bayes on a project. Okay, we took a data set and we have implemented naive on a data set. And later on, we also understood the concept of decision tree, right? How decision tree works, what are the important nodes. We discussed about root node, branch node, nothing but internal node, and leaf node. Okay, why it is named as a greedy algorithm, what exactly it is greedy about. Okay, so each and every important point with respect to decision tree was being understood. So friends, if you are not aware of decision tree algorithm, how it works, okay, whatever the terminology that I was using so far, if you are not aware of those topics, just go through the previous video. I have completed a session on decision tree, how the algorithm works, and this particular session is the continuation to the previous one. Okay, so in this session we are going to implement how decision tree is implemented on a use case. Okay, so for this I have took a data set, okay, where we are going to build a decision tree model for predicting breast cancer, right? So this is one of the uh, you know, the disease that is being attacked more, cancer, right? An unwanted tissue growing inside a body which is leading to cancer, right? So we are coming up with a model using decision tree algorithm. I'll implement a decision tree and I'll come up with the model, and this model helps us to predict breast cancer in humans, right? Especially in the female body. Okay, when we pass all the inputs, when we pass these inputs to our model, and model is capable of predicting the output. So before I explain before we get understand how we are going to do or how we are going to implement a decision tree, let us go and have a quick review on the data set. Okay, so you see, we have inputs like mean radius, mean texture, mean perimeter, mean area, mean smoothness. So all of these are some inputs, okay, which talk about the cancer tissues that grow inside of human body. So the question comes, Akhil, I'm not aware of all these, no, the terminologies that you are using. So, friends, if you are from life sciences healthcare, okay, especially if you are from life sciences healthcare domain, probably you may understand all these terminologies. But even though if you don't understand in real time, what happens is you'll have domain experts, and these domain experts they help us. Okay, if you have any questions with the domain related questions, they are going to help us. So all these are inputs. See how many inputs I have. So that means I'm going to use all these inputs to predict an output. What is output? It is cancer type. It is cancer type. So do we also have types in cancer? Yes, obviously we have, you know, stage 1 cancer, stage 2 and all, right? But this is something not related to those types. You know, we are talking about whether a patient have cancer or not. That's it. Only two classes. Benign means the cancer tissue that was growing inside the body is not cancerous, it is not harmful, but malignant is harmful. So whenever the patient walks in, we'll capture uh, probably part of the tissue will be cut, and from the tissue we'll get all the inputs. The details will be captured for all the inputs, and When you pass all these inputs to your model is going to predict whether it is benign or malignant. Only two classes, benign or malignant. So benign is not harmful. So no, it's not a harmful tissue that is growing inside the body that can be removed. But malignant is harmful, right? So if malignant was predicted by our model, yes, the patient has to undergo some treatment. That is what we suggest, right? Now, you know, I'll go back. Anyhow, there is data dictionary provided. So I have the meaning for each and every input, what exactly each and every input says, mean radius, mean texture. So you need not be aware of all these things because you see, we have probably, oh my god, there are 30 inputs. 30 inputs I'm using to build my model. Okay, so if you talk about decision tree is a rules based algorithm. It's a rule based algorithm. And moreover, all the inputs that I have, all of them are they discrete or continuous? Are they discrete? No, they are continuous, right? So what happens is this particular decision tree algorithm, whenever you have discrete continuous variables inputs, it tries to bin group. Okay, it groups all the values and you know it starts splitting the data set into sub data sets. Okay, your data set will be partitioned into subsets by identifying one of the main input as root node. So we also discussed, right, how a column is identified, how a feature of or how a attribute of the data is identified as root node. We have discussed. We understood the concept of entropy, which is a measure of impurity, okay, randomness, and we also understood the concept of information gain, entropy before the split minus entropy after the split, the difference. So by calculating the entropy for all the features and by calculating this information gain, whichever feature is having highest information gain, that particular attribute, that particular feature will be identified as root node. So friends, that's what. If you are not aware of decision tree algorithm, go through our previous session. Okay, I have done a separate video for decision tree algorithm, how it works, what are the important components, okay, and what are the measures that we consider as part of this decision tree algorithm have been explained clearly. Right. So let us start the use case. So the first step is importing the required packages, whatever the libraries that we have, we are supposed to import them. So I'm using Spider, okay, one of the IDE for executing, for building my model. I'm using Spider and I'm implementing Python. Right. So I'm importing Pandas as PD. Pandas is a library for data manipulation. Okay. Then from Matplotlib, I'm importing PyPlot as PLT for data visualization. Good. From SciPy, I'm importing from SciPy.stats. I'm just importing randint to generate some random integers. Yes, I'm importing randint. Yes, it's done. Then from feature underscore engine dot outliers, I'm importing Winsorizer for treating outliers. See, we have the output coming in the console, friends. Focus on the console as well. Then from scalar dot preprocessing, I'm importing minmax scalar for feature for performing feature scaling. I'm importing minmax scalar. Then for performing auto EDA, I'm using Pandas profiling library for automating the EDA process. Train test split from sklearn model selection is being imported to split the data into train and test data sets. Done. Then finally our main function decision tree classifier I'm importing from sklearn.tree. So using this particular function, I'll be creating our model. So our model gets trained when we pass the data to this function, right? Then accuracy score, classification report, confusion metrics as evaluation metrics. I'm going to import all these metrics to evaluate the model that we have built. Then randomized search CV. So for hyperparameter tuning, I'm importing randomized search CV from sklearn.model selection. And finally, joblib. Joblib is for saving and loading back your trained models. So the model, once after getting trained, you're supposed to save it. Why? Only if you save it, you can use it on the upcoming data, future data, right? So let me import it. I'm done. So I'm done with all the required libraries importing. I have done, I'm imported all the required libraries. Now let us start the process. The first step, as we have the data present in a Excel file, okay, what am I doing? I'm supposed to read the data set. So in Pandas, there is a function read underscore Excel. Okay, so pd dot read underscore Excel is a function. Within this function, what am I doing? I have specified the path. I have specified the path. So this particular path at this file, I mean in this particular location, we have the Excel sheet named as breast underscore cancer. So breast cancer dot xlsx represents our data set. Okay, so I'm reading the data set and I'm storing the data in a variable data only. Is it done? Yes. So what is the size of my data set? 569 rows by 31 columns. So that means each and every row talks about each and every row talks about details of a patient. Am I right? Yes. So that, what does it imply? It says that we have the data of 569 patients. Okay. And all these 569 patients, from all these 569 patients, we have observed the tissue growing inside the body, and a part of it was being cut, and we have sent it to the lab. We got the reports, and that was documented. Once after documenting them, we after recording all these details of the patients, we also understood whether the patient has cancer or not by performing some kind of treatment. So this is all the data that you see here is historical data. It is just historical data, friends. Okay, so using this historical data, the past data, I'm going to build a model using decision tree algorithm. So this particular model will help us to predict on the future data. So whenever a new patient walks in, so initially again the same process will be repeated, but once after getting all the details, all the inputs, I'll pass to my model. I'll get the result from my model. I'll get the prediction from from my model. Okay, so accordingly we'll suggest to that particular patient. That's how we are going to use our you know um, decision tree algorithm for predictions. And it's a two class problem where we have only two classes. One is benign and malignant. Benign is non-cancerous, malignant is cancerous. In simple, benign is not harmful, malignant is harmful. So just remember in that way, right? What does info function written as, friends? What does info function written as? Info function will return the complete information about the data set. number of columns, number of rows, the non-null count, the data types for each and every column will be given as output. See, for all the columns, so if I make, probably you can see here 569 rows. This is the index. By default, index in Python starts from 0. So 0 to 568. In total, 569 entries, nothing but rows, and total 31 columns. Here we have the list of column names, their index, and what is a non-null count. So that means it is also talking about the null values. What is the count of null values and the data type? See. So what can you observe from it? I see there is no null value, and moreover, all the inputs are numeric, continuous. So need, right? So now let us go a bit further. What am I doing, friends? What am I'm using a function value underscore counts, okay, which is get the count of each and every distinct value present in that column. So what does this mean? Data of cancer type, that is nothing but in data in your frame you have cancer type y column, right? So in this y column, get the value, I mean return all the distinct values and their counts is what we are trying to get. Value underscore counts is a function which returns all the distinct values along with the count of that value in that particular column. So I'm taking y column. Why am I doing it? In order to check whether the data is balanced or imbalanced, I'm supposed to, you know, check this upfront, right? So let me execute this. Benign is 357, malignant is 212. Is it balanced, friends? I need data. What is imbalanced data? Then, okay. See, what is the overall count? 570. 570 is 100%. What is 10%? 57. Yes. What is 30%? So 57 multiplied by 3, average it will be around 180. So if you want the exact answer, it will be 177. Sorry, 171. Right? Yes. So each and every class should have at least 171 values. Only then it is balanced data. Only then it is balanced data. Okay. So let us execute this. I can clearly see it is a balanced data because each and every class have greater than 171 values. So it is clearly indicating that it's a balanced data set, friends. Okay, right. Then what is the next step? Let us start with the process. The first step of the project is doing EDA. So I'm completing the EDA process. So as part of EDA, I'm using pandas profiling to get the detailed report about, the data set. So I'll execute this. It's done. Now I want the results to be stored to a HTML file. Okay. So let us also execute this one. The second one, 96 line. You observe the output, the console part. It carries out for each and every input as well as output. Okay. So it starts building the report and saves to the HTML file. Once if it is created, once if it is saved, let us go and understand the results, friends. There are many automated libraries for EDA. Okay, so one of these libraries is Pandas profiling. Apart from Pandas profiling, we have SweetWiz, AutoWiz, Detail. Okay, then many. There are many automated EDA packages. It's taking good amount of time. The main reason is our data set has more number of columns. So it should go through each and every column data, right? So it is taking time. That's okay. So as an experiment, try using other automated EDA packages so that you'll have a good exposure for the automated packages as well. But do entire EDA manually. Okay, carry out first movement, second movement, third movement, fourth movement, data visualization individually. Don't use any automated packages. Hmm. Let us wait for a couple of minutes. It executes all the calculations. I'll show you the report. Okay, once if it is saved. So where will this report get saved, friends? Where this particular report will be saved? Can you tell me? Use chat. In the current working directory. What is my current working directory? Where I can get the information from the current working directory about my current working directory? Since I'm using Spider, there is a shortcut. How can I know the current working directory? Yes, you see here in Spider, in this rectangular box, it displays you your current working directory. Okay, so if you are using any other IDs, okay, so you have to use a function called getCwd, which is available in OS library. Okay, so from OS module, you are supposed to import this. I mean, use that function to get the information of current working directory. That's it. It's taking time. Anyhow, I have written the insights from the output of that particular file, from the HTML file that we get from here. You see next to the line 97, we have insights in line number 99. No missing values. Anyhow, we know that the information from info function itself, and no duplicate rows. So that means there are no duplicate rows as well. So what other features, what are the pre-processing steps to be done? We'll discuss. But it's taking time. I don't know why this much time it's taking. As we had more number of columns, yes, that might be the reason for it. Hold on, friends. Or shall we skip this part? What do you say? It's taking time. The main reason is the size of the data set. We have more number of columns. If you want me to skip this part, I'll stop this current iteration. Then we can go to the next level of code. Yes, good. So I understood it's taking time. I'm stopping. I'm interrupting the kernel. Okay, done. So friends, anyhow, you'll get the same HTML file. That's not an issue. Even you can run the same code in your system when you're free, right? So let us go to the next part. It is data pre-processing. Okay. So in data pre-processing, we are supposed to do all the cleaning steps, the transformations, feature scaling, handling missing values, all these steps. So before that, what am I doing? Can someone tell me what am I doing in line number 105? Respond. Try to understand the code from here onwards. Let us understand the code. What am I doing in line number 105? So it's very simple. Data represents our data frame. Okay. Drop. Data represents our data frame. From our table, I'm dropping a column. It is cancer type. So what happens when I execute this? So that means I'm removing Y column from my data frame. So obviously It contains only inputs. Where am I storing those inputs? I'm storing those inputs in X variable. See, so 31 became 30. Ah, so your Y column was being removed. So that means X contains only inputs. What am I doing in line number 106? I'm taking from the data frame, I'm just considering only one column. I'm referring to only one column. It is cancer type. So that means it is just only output. So I'm storing the output in Y. So the same number of rows, but it is only one column. So it is a series. It is a series object and X is a data frame object. I hope you are aware of the difference between series and data frame. Okay. So friends, if you are new for Python and if you are not clear about the basics, do watch our 30 days free short-term training from Python to AI. All the basics were being covered as part of that particular playlist, right? Then what is the next step? Let us, you know, create a box plot to identify whether we have outliers or not. Okay, what am I doing? I'm creating box plot. This is the code. This is not the, full code. So for making that visualization, I have expanded it. So I'll just go through. I'll show you. See. So this is how my box plot looks when I try to visualize for all the columns in a single go. All the 30 columns, 30 inputs, and these are the values. For some columns, as the values are very big, so the scale is very high on the y-axis, and for some columns, as the values are very small, you are even not able to interpret them. Am I right? Yes, but that's okay. I can understand that, from all the columns, only in one column there is no outlier. Apart from it, in rest of all the columns there are outliers. So what am I supposed to do? I have to treat them. There is no other alternative, right? Yes. So let us start using winsorization. I started using winsorization. Winsorization is a technique used for handling outliers. If you have outliers in your data and if you want to treat them, winsorization is the technique implemented. Is one of the technique. So what am I doing? I'm keeping the capping method as IQR and the tail at both the tails. Okay, I want the outliers to be displayed. Okay, to be treated off, and the fold that I'm keeping is 1.5, and I'm passing a list of columns. What is the columns? They are from X. X is nothing but inputs. So all the 30 columns will be, you know, used, and I'm executing. I'm done. So I've just, have just defined Winsorizer. This particular Winsorizer, after defining, I'm using it and I'm applying it on inputs X. I'll fit and I'll transform the results. All these results will be stored in clean underscore data variable. Is it done? Yes, I'm done. Just have a look. What is the size of clean data? 516 comma 30. So all these variables that we have passed as part of inputs were being treated with outliers. To ensure whether the outliers are removed or not, I'll run the same code again, but this time not on the on the original data. On which data I'm going to visualize box plot? On the clean data. So let me execute. Do you see any outliers? No outliers. There is no outlier in any of the column. So initially we had outliers. I implemented winsorization using IKR method by keeping fold as 1.5. What happened? Winsorization is capable of, you know, handling the outliers for this particular data. I'm talking about this data. Okay. So all outliers got treated, friends. I don't see any of the outlier in any of the column. No outliers in any of the column. So the next step is scaling. So as part of scaling, what am I doing? I'm applying min-max scalar. I'm applying min-max scalar. Can someone tell me what is the formula for min-max scalar? What is the formula that is used for min-max scalar, friends? Min-max scalar uses formula x minus min by max minus min. Yes, it is part of feature scaling. So, it uses the formula x minus min by max minus min. I'm initializing it. Then, once after initializing, I'm using that particular scalar, okay, on the clean data. It's not on the inputs. The output that we get from winsorization, on that data, I'm fitting and I'll get the transformed results and I'll store it under clean underscore x. Yes, the output of min-max scalar will be between 0 to 1. Anyhow, I'll show to you, friends. So this particular output is an array. They're converting back to data and have a look on clean underscore x. All the values, you see any value greater than 1 and any value less, impossible. Impossible. Why? Observe the formula x minus min by max minus min. So the maximum value that you can get is 1 and minimum value that you can get is 0. Right? So I'm done with all the steps of pre-processing. Now I'll start my model building phase as part of CRISP ML. So the first step is splitting the data. What am I doing? I'm using train underscore test underscore split function and I'm passing clean underscore x, the output that we got from pre-processing. Okay. And the y values, the original y values, and the test size is 0.2. That means 20% should be assigned to test data. Then 80% of the data will be stored in train. So train dataset will have 80%, test dataset will have 20%. Random underscore state, it talks about, you know, even though if you run the same algorithm for multiple times, the observations between the train and test should not be changed. If they change, the output will change. So to ensure the same split happens at every time, we use random underscore state as a parameter, a very important parameter that has to be learned. And you'll get 4 parts. I mean, under test you'll have 2, under train you'll have 2. Under test, x test, y test, inputs under outputs under the test data. In the same way, under train, inputs, output. So let me egg them. So you'll have all the 4 parts. Clear? Now let me initialize my decision tree function, the model, with the parameters like criterion. I'm taking Gini and the random state as 1. If minimum samples under the leaf are 1, you can stop the growing of your tree. So for that, I'm initializing decision tree classifier. The function is decision tree classifier, friends. So we discussed decision tree algorithm can be used for both regression and classification. If you are working on a classification task, the function will be decision tree classifier. If you are working for a regression task, the function will be decision tree regressor. Okay. So since this is the classification problem, I'm just using only decision tree classifier. Right. So Once after the model initialized, I'm fitting the model on the trained data. Done. So the model got trained. Now this particular model I'm using to get the predictions on test data. Whenever you want to get the predictions for your data set, you're supposed to pass only input. That ycap you're storing in ypred. So ypred is my predictions and ytest is my actual minus prediction will give us error, right? But the question comes, Akhil, this is a non-numeric column. How can you get the difference between a non-numeric column? Am I right? Yes, it's impossible. For that reason, we calculate accuracy. Accuracy is nothing but whenever your prediction and your actually same, you know, that represents a true case. If it is predicting wrong, it will be a false case. Okay, so the formula for accuracy, I hope you remember: true positives plus true negatives by all the four different cases: true positives, true negatives, false negatives. Let me print the accuracy to the 94 percentage. 94 percentage I have got on data set. So what is the error, friends? Obviously 6%, because you know accuracy plus error is 100. When you sum up accuracy and error, the percentage is 100. Accuracy is 94, the error is 6%. And I'll get the confusion matrix on the test data itself again. Let me print the confusion matrix to the console. So in 68 cases, it has predicted correctly, and in 39 cases also it has predicted correctly, but wrong. Okay, so this is our false negative and this is our false positives, right? So this false negative is very dangerous, friends, because it says that your patient has cancer and the model says no cancer. So when the model says no cancer, that particular patient will not go under any treatment. So there is a chance of that patient dying. So it is very important that you are supposed to make this false negatives close to zero. Okay, observe. And I can also get the classification report where I'll have precision, recall, all the values. See, so this is my precision. Overall, it is 0.94 average, and recall is 0.93 FPR. Sorry, TPR, true positive rate, and F1 score is a harmonic mean of precision and recall. 2 times of precision into recall by precision plus recall score, and F1 score will lie between 0 and 1. If the value close to 0, if the F1 score is if the value is close to 0, then we say the model that was built is a bad model, and if it is close to 1, we say the model that is built is a good model. So obviously we have built a good model, right? Then I'll do the same on train dataset as well. I'll get the predictions. I'll get the accuracy calculated. Oh my god. You see here, the main disadvantage of using decision tree is it gets overfit on the model. What is overfitting? Overfitting is a case where you get 100% accuracy. For trained dataset, it says 100%. So if any of the model, if it is giving 100% accuracy, it's overfitting. No, it should not result as 100%, right? So that is the reason we are supposed to retrain the model. We have to change the parameters, right? So I'll get the confusion matrix for the test data train data set. See, for all the records under the train data set, it is predicting exactly. There is no false positives and false negatives, zero. So this is something danger. And whenever your model gets overfit, you're supposed to do hyperparameter tuning. And especially in decision trees, there is a technique called pruning. So pruning has to be implemented to stop overfitting as part of decision tree. Okay. Then I'll also get classification report for train data set. So I should get F1 score 1. See, F1 score is 1. This is not accepted, friends, in real time. For that reason, what am I doing? I am coming up with all the different combinations of, you know, the parameters that are available inside decision tree. Criterion. I'm taking Gini, entropy, log loss, maximum depth that the algorithm can go. So I have took some values, random values, and minimum sample split between 2 to 20, minimum samples under the leaf node 1 to 20, maximum features. Okay, it is square root and log 2 can be applied. Splitter is best and random splitting is also accepted. Maximum leaf nodes some integer between 10 to 100 is accepted, and random state is 42. These different parameters I am going to take and start my tuning. I'll start my hyperparameter tuning by using randomized search CV. Before that, I'm defining my decision tree classifier with random state 1. Okay. And so far, in the previous sessions, we understood grid search CV. But if you try to use grid search CV in this case, it takes lot of time. Why? Grid search CV is a hyperparameter tuning, technique which helps us to get all the possible combinations as part of the grid. But randomized search CV will not go for all the possible combinations. Randomly it takes the values and it gets the combinations done, and out of all the combinations it tries, it gives us the output. Right? So that makes the difference between grid search CV and randomized search CV. So I'm taking randomized search CV and the estimator is tree. Param distributions, I'm taking the same param distributions. Okay. Iterations I'm taking as 100. The scoring that I want to consider is accuracy. CV cross validations I'm taking 5. Okay. And random state 42. Okay. So that 42 will be used time again at all the different combinations. 42 will be used, and n jobs whether to use all the cores or not should be decided, and verbose is equals to 1. So let me execute all this together. I have initialized randomized search CV done. This randomized search CV I'll make to fit on my model, okay, by passing train data. See how much time it takes. This is what we do as an experiment in real time. Observe, friends. Is it done? Yes. Now let me get the best parameters out of all these. The best parameters from the model has, trained is best parameters. Criteria maximum depth should be 15. Maximum features are none. Leaf nodes, minimum sample leaves 8. Sample split is 13. Random state is 42 and the splitter is random. So these are the best features that we have got. And what is the accuracy that we have achieved? 0.95. 95% accuracy we got, friends. Okay, so let us predict on the test data using this best combination parameters. Okay, so it's done. I got the best parameters saved. I'll use it to predict my test data set. I'll get the accuracy. I'll print it. 0.95. On the test data, it is once after getting the results, get the classification report as well. So the good model we have got, and finally I'm saving the model using joblib. Using job, I have saved my model. What is my name of the model? The name of the model that I have used is dt.pkl. For saving the model, I'm using joblib.dump function. Okay. So which one has to be saved? Best underscore tree. Where is this best underscore tree? Here. This one I'm saving using open function with the name as dt.pkl. This will be the name of this particular file when it is saved in the local machine in right binary format. Okay. So this particular file will be saved in your current working directory. So if you want me to show, so here, yes, where is it? Did it change? It has to get saved. Okay, somewhere it's going wrong. It has to get saved in the current working directory itself. Let me do it one more time. Is it missing? Okay. Sorry, my bad. Why am I checking here? It's C users user, right? My bad. C users user. So this is my file. I hope it's making sense, friends. So I have saved the model, and this model will be used to predict my future data, my new data, right? So this is how we implement decision tree algorithm on a real-time project. Initially, the problem with decision tree is it gets overfit. This particular algorithm gets overfit on the data 109, 110, 113. Okay, 109. Acha. So, guys, see, this talks about, see, I'm getting the visualization, right? Okay. So, whenever I'm trying to get a visualization, I have to define some values to the plots. Okay. So, I'll explain. No worries. You see here, this is the plot that I have got. In order to get this plot, I have to write the code. Okay. What is the first one talking about? It is talking about the subplots. Within this plot, I should have subplots. Okay. Subplot is a function from matplotlib.pyplot. PLT represents pyplot. Okay. How many rows? N rows is equal to 1. Only one row. And number of columns is also 1. But the figure size should be 30 by 10. 30 by 10. Then I'm plotting. I'm using plot function to plot. What kind of plot you want to get? I want box plot. So under kind, you give the value as box plot. Subplots, yes, make it as for. And the figure size of each and every plot should be 30 by 10, and it share the axis of this particular axis. Okay, from each and every subplot, okay, they have to adjust it. They should be adjusted in such a way that I am using a function called subplots underscore adjust. This subplots underscore adjust takes the values of bottom 0.3, left 0.05, The spacing between each and every plot, what should be the space? You have to fix. Okay, the right, top, and width space. Okay, so these should be the values. And finally, your title for your entire plot. Box plot for input features. Then what is your title for X label? It should be features. Features. In the same way for your Y axis, I want values. Y label as values. I hope it's making sense. So all these lines of code helps us to get this single plot. So together you have to run all the lines to get one visualization. It's not easy because you're not visualizing one column at a time. All the 30 columns I'm visualizing. So that is the reason I'm expanded. I have included more steps. X sticks. This actually represents the scroll bar to move between your plots. I mean between the one to the other. But anyhow, you did not have any bar. In general, you should also get a bar to move between the plots. But no, right? So when you execute, let me do it one more time. Is it making sense? Okay, so this way it is okay. So x6 is actually representing, you're taking the values of what the inputs, right? So this should have the names given. So they should be rotated at 90 degrees, and you will have the name of the column. To which column it is representing, the box plot representing. See, and all of these column names will be aligned at 90 degrees angle. So horizontal name will be shifted 90 degrees, so you'll get a vertical name. I hope it's making sense. And finally, show function will give you the box plot, the plot. Got it? Yes. So I'll stop the session here. Anyhow, we had a clear understanding on whatever we have gone through the session. So friends, before you leave, just hit on the like button. That will be a kind of encouragement that we get from you. And moreover, do share across your connections. Okay. And if you have any kind of questions, do post them in our comment section. We'll respond to your comments. And the feedback link has been provided. Give a valuable feedback before you leave. That's all for this particular session. Again, we'll catch up in the next session. Until then, have a great day. Signing off. Bye.